Chapter 05. Oscillating Universe Theory. The idea that our universe might go through endless cycles of birth, death, and rebirth has fascinated humans for thousands of years. The modern oscillating universe theory started with Alexander Friedmann in 1922, who used Einstein's equations to show that a universe could expand and contract in a repeating pattern. Richard C. Tolman later studied the energy implications of such cycles in the 1930s. What is the oscillating universe theory? The oscillating universe theory presents a radically different picture of our cosmos compared to what most people learn in school. Instead of the universe having a single beginning in the Big Bang about 13.8 billion years ago, this theory suggests that the universe has no real beginning or end. Instead, it goes through infinite cycles, like a cosmic heartbeat that has been beating forever and will continue forever. Each cycle in this model follows a similar pattern. The universe starts in a hot, dense state and expands outward. Just like in the Big Bang theory, stars form, galaxies develop, and life might even emerge on countless worlds. But unlike the Big Bang model, where the universe might expand forever or eventually stop expanding, the oscillating model says that gravity will eventually win the battle against expansion. The universe will start contracting, pulling everything back together until it reaches another extremely hot, dense state. This contraction phase is sometimes called the Big Crunch. However, instead of ending there, the universe bounces back and starts expanding again, beginning a new cycle. This model offers several interesting advantages over the traditional Big Bang theory. First, it avoids the uncomfortable question of what came before the Big Bang, because in the oscillating model, there is no before. The universe has always existed in this repeating pattern. Second, it solves what scientists call the singularity problem. In the Big Bang model, everything started from a single point of infinite density and temperature where the laws of physics break down. The oscillating model replaces this impossible singularity with a bounce that, while still extreme, doesn't require infinite conditions. Historical development and modern advances. The mathematical foundation for the oscillating universe began with Alexander Friedmann's work in 1922. Friedmann discovered that Einstein's equations, describing gravity and the shape of space, allowed for a universe that could be closed, meaning it would eventually stop expanding and start contracting. This was a revolutionary idea because it showed that the universe's fate wasn't necessarily to expand forever. Richard Tolman built on Friedmann's work in the 1930s by examining what would happen to energy and entropy in such a cycling universe. Tolman discovered a significant problem. Each cycle would produce more entropy than the previous one, meaning that each new cycle would be longer and larger than the last. This implied that if you looked backward in time, previous cycles would have been shorter and smaller. This created a puzzle because it suggested that the cycles couldn't have been going on forever in the past. There must have been a first, smallest cycle. This thermodynamic challenge made many scientists lose interest in the oscillating model for several decades. However, new discoveries and theoretical advances in the late 20th and early 21st centuries brought the oscillating universe back into serious consideration. One of the most important developments came from Paul Steinhardt and Neil Turok in 2001. They proposed a completely new type of oscillating model based on string theory, which suggests that the fundamental building blocks of reality aren't particles but tiny vibrating strings. Their model imagines that our entire universe exists on what they call a brane, a multidimensional membrane floating in a higher dimensional space. According to their theory, this brane periodically collides with another brane, and these collisions create the Big Bang-like events that start each new cycle. This brane collision model elegantly avoids the singularity problem and helps explain the role of dark energy in driving cosmic expansion. Another interesting variation came from Laurice, Baum and Paul Frampton in 2007. They proposed a model involving phantom energy, a hypothetical form of energy that causes the universe to expand so rapidly that it literally tears apart all matter, down to the smallest particles. After this complete destruction, the universe somehow contracts and begins again. Roger Penrose, a Nobel Prize-winning physicist, developed yet another version called conformal cycling cosmology. In Penrose's model, the universe goes through infinite eons, with each eon ending when the universe becomes completely smooth and empty. This smooth, empty state somehow becomes the starting point for the next Big Bang, creating a new eon. Scientific and philosophical foundations. The oscillating universe theory draws on several areas of modern physics and addresses some deep philosophical questions about the nature of existence. From a scientific standpoint, the theory is grounded in Einstein's general relativity, which describes how gravity works by warping space and time. Friedmann's solutions to Einstein's equations showed that a universe could indeed expand and contract in cycles, providing the mathematical foundation for the entire theory. The theory also incorporates our understanding of thermodynamics, the science of heat, energy, and entropy. While Tolman's early work highlighted challenges with entropy in oscillating models, modern versions attempt to address these issues through quantum effects and the properties of dark energy. Speaking of dark energy, this mysterious force has become crucial to modern oscillating models. In 1998, scientists discovered that the expansion of our universe is actually accelerating, driven by something they called dark energy. This discovery revolutionized cosmology and forced theorists to reconsider how cosmic cycles might work. In many modern oscillating models, dark energy plays a key role in both the expansion and contraction phases of each cycle. The theory also draws on cutting-edge ideas from quantum gravity and string theory. These theoretical frameworks attempt to describe what happens when gravity becomes as important as quantum effects, conditions that would exist during the bounce between cycles. While these theories are still being developed and tested, they provide tools for understanding how the universe might transition from contraction to expansion without creating impossible singularities. From a philosophical perspective, the oscillating universe has tremendous appeal. It addresses the ancient question of whether the universe had a beginning by suggesting that it has always existed. This removes the need to explain what came before the Big Bang or what caused it to happen. The idea of cosmic renewal and eternal cycles resonates with many philosophical and religious traditions that view time as circular rather than linear. Conclusion: the oscillating universe theory offers an ambitious alternative to the Big Bang model, suggesting our cosmos undergoes endless cycles of expansion and contraction. While it elegantly addresses problems like cosmic singularities and the universe's origin, significant challenges remain, including thermodynamic issues and lack of direct observational evidence. As our understanding of dark energy, quantum gravity, and string theory advances, the oscillating universe remains a compelling possibility that could reshape our understanding of cosmic existence and time itself. Next video, Chapter 06, Creationism Explained. Thank you for watching. Hope you got a clear idea about the oscillating universe theory. If so, please like, subscribe to watch more videos and share with like minds.